Hello and welcome to the latest episode of Word on the Snake Vine. I'm your host Ross Deacon, and on this podcast we talk all things about venomous animal related, from venom research, venomous animal husbandry, animal conservation, herping, and of course snake bite and snake bite initiatives from all around this world. On this episode, I have joining me as my co-host.
Hi, I'm Denny.
Hi, I'm Med. And before we start, I have to do a few formalities. Any views expressed in this episode are the views of the guest host, not for the facility or the company they work for.
And today, this is going to be our final episode of our Summer of Toxins month, where we have had 5 different episodes talking all about different types of toxins, different types of conservation within those toxins, all big, massive name guests within their fields. And today is probably one of the most excited that I've been for a guest, and I know Squirl has been as well for a guest. And today we have Justin Schmidt, author of The Sting of the Wild and Professor of Biology at the University of Arizona, joining us. How are you today, Justin?
Good. And you?
Oh, I'm absolutely fantastic. I'm
Awesome,
genuinely
thanks.
dead excited about this, especially after a week of falling off roofs and stuff
Jeez.
myself. So this is going to take my mind off it, and hopefully we'll have your fascinating story about the work you've done over the years. So I think we'll start at the start, shall we? So where did your fascination with insects kind of begin?
I think my fascination with insects actually began before my memory, because I don't remember anything before 3, but about as soon as I got to 3 or 4 or 5, I was just always interested in creepy crawlies. And where I was growing up in the mountains of the Appalachians of Pennsylvania, about the main creepy crawlies we had besides earthworms were insects.
Nice.
Yeah, that's so kind of how did that develop into your kind of the fascination with I can't spit my words out today.
Hymenoptera.
Yeah, Hymenoptera specifically come from.
Well, I think one of the reasons I was interested in Hymenoptera is most kids were interested in the beautiful things, the impressive things, and those include butterflies and a few moths. And well, Hymenoptera in that category too, because most of them are fairly good sized for insects, and they have yellow and black and red and nice colors on them, and they're active, they flit about, and so they're kind of like a funny shaped butterfly. There's something that attracts your attention, and that along with dragonflies were my childhood loves.
It's a very odd set of insects to be fascinated by. Most people have got a bit of a phobia of them, whereas you obviously don't.
Took the opposite signal from the aposematism.
Yeah, I have more of a phobia from big things, like put me in front of a huge horse or something. I said, look at how big that horse is. It can stomp me into nothing, and so I'm more timid around them. Whereas, most people think a horse, oh, good, I'll go and ride that, but don't get that bee anywhere near me.
Incidentally, horses is a common fear of my own, as well as butterflies. I don't mind most flying insects, but butterflies, moths I don't mind either. Butterflies, no go. Do not like them in the slightest.
Reminds me of a gal. I was on a hike in Utah, and this teenage gal had the smallest butterfly I'd ever seen. It must have been a centimeter across wingspan, a really tiny little thing. And it landed on her shoulder, and she just panicked. I thought, oh, good grief. Thought, well, everybody's got their phobias, and I'm glad mine isn't butterflies.
Yeah, definitely.
Yeah. I'm usually, I will admit, I'm usually okay. I will just kind of, I'm not one of these people who'll make a scene. I just walk the other way, but I won't go into butterfly houses and stuff like that if by choice anyway. So, it kind of, hopefully.
Just hold your breath and grit your teeth.
Definitely. Speaking of Hymenoptera, though, I do have a bumblebee just about to hit me in the face, it seems.
It must have known.
Yeah, bumblebees are actually one of my favorites as well. I don't study them much. I just like them because they're quite beautiful and they're quite beneficial, and they do fun things, and they're locally available wherever you are. It seems there's always a nice bumblebee to cheer up your life, and just a good insect.
They are cool.
They are cool, very cool. Yeah.
So how did you go from having an interest as a kid to actually forming your academic career and basically taking your path into entomology, into where you are today?
Yeah, I took kind of an indirect path. I was going through school and I first had biology, which was the first science subject that we had. And I really liked that and I wanted to be a biologist. Then I took a chemistry course and I thought, wow, or no, I took a physics course next. I said, wow, physics is really cool. So I decided I was going to become a physicist. And then I took a chemistry course and decided I wanted to become a chemist. Well, that was the last course I had. So I enrolled in university in chemistry and completed a bachelor's and a master's in chemistry. And then I got to thinking, gosh, this is awfully boring sitting here in a white lab coat smelling nasty, evil chemicals and solvents and things. All my friends are out there doing things at the beach, studying marine biology, or up in the mountains, studying Arctic biology or something of that sort, doing fun things. And here I am in the lab. So I decided to change to studying biology, in this case, insects. And I went to a program and I said, well, what am I going to do? I'm a washed up chemist. And, actually I was a pretty good chemist, but I was washed up as far as my attitude went. What can I do with insects and chemistry? And there was a whole new field of insect chemical communication and the toxinology of their venoms and that sort of thing. So that's how I transferred into entomology. I kept what I had and just expanded my interests.
That's quite a good route in. I went the opposite way, where I was mainly zoology and I hated chemistry, and then kind of went back around to the venom side of things, and now I've got to relearn all the things that I hated.
Yeah, well, that's one of the disadvantages of doing that. I'm constantly being asked by my family about chemical things, and I stopped my chemicals academic studies about 40 years ago. And so fortunately, I have a good memory for trivia, things like chemistry, so I can still be fairly conversant in the subject.
Yeah, that's quite interesting. It's quite an interesting route into entomology and into biology. I think a lot of people think that once you finish university and you've kind of got yourself on a career, either a set career path or a set research path, that you have to stick with it. When reality of it is that, like yourself, that there's crossovers between a lot of the different sciences. And
Yeah, if you don't keep changing, you're lost. You got to always go for whatever the newest information, the greatest stuff that you can do, and you got to alter and just go with the flow. You can't just stick with, well, I'm going to do the same thing I did when I graduated for the next 35 years. That's not going to work very well.
Just stagnate in the one position.
Exactly.
Yeah, I think that's really quite interesting. It's good to hear somebody respected like yourself come out and say that as well, and say that sometimes it is better to go around the hill and you'll come out and into the actual research field that you're in with a different knowledge set compared to somebody who's just done that as well. So kind of how did you go from starting to study biology and entomology to actually coming up with the idea of the pain index?
Basically, what I was doing is in the 70s and 80s, when I was formulating this path, there was a hotbed of theoretical research, especially coming out of Europe and Britain. W.D. Hamilton was one of the great theorists. And at the time, all of the studies were involved in how did insects become social insects. In other words, they changed from a solitary insect that just flies around on its own to living in massive colonies. And the questions were all, how did they do this genetically? And so that was what was being done at the time. And I took a different approach. I said, well, yeah, I understand the genetics and all the natural forces that are making this possible. But you got to get there. You got to go down the road. And what's this road like? And nobody was talking about the road. The road was fending off all the predators who want to eat you along the way. And so I said, well, the only way you can do that is by having a defensive system that's stronger than any of your predators, or at least stronger than enough of them so that you can progress forward. And so I said, the only system I can think of that does that is the insect sting. And so that's how I got involved in stinging insects as the proximal mean to evolve sociality and colony structures. So then, having come up with this hypothesis, said, well, now how do you test that? Ideas are great. Hand waving is a fun thing to do at the pub and all that. But push comes to shove, you got to come up with some evidence rather than just words. So I said, well, I can measure, if I can measure pain, then I can say, well, the things that are more highly social should hurt more when they sting than the things that are solitary. So in order to do that, you have to be able to measure pain. And then I got to realizing, oh, gosh, there's no way to measure pain. So I said, well, we'll just have to make one then. So what we came up with was this insect sting pain scale of 1 to 4, which is based on a 2 being a honeybee. And basically what most people have been stung by a honeybee, walking through the park and you step on one or something, and you remember, ouch, that hurts. So keep in mind, how much the honeybee stung. So then you come along, you get stung by something else, a common wasp or a sweat bee that's around in this country, at least right now in this time of year, or an ant that stings you, something of this sort. And the scales basically say this sweat bee stings you when you're having a nice cool drink in the afternoon out by the swimming pool, and you compare the pain of that sweat bee sting to that of your honeybee sting you had earlier. And if it's about the same, you call it a 2. If it's a whole lot less, which is the case of the sweat bee, then it's a 1. It would be a whole lot more, which in this case, I don't think you have anything in Europe, which, well, yeah, you would. You'd have some of the giant hornets, some of the big hornets you have
Yeah.
would be a 3. They'd be substantially more than a honeybee. So if it's a lot more than a honeybee, it's 3. Then when you get to the 4, you don't want to go there.
So from that, how did you set the controls for the sting? So you say you were matching it back to the honeybee each time, and where it was on the pain scale regarding from a honeybee. How did you, after years of doing this, how did you still kind of bring it back to that kind of to that?
Yeah, it's
that
kind
control?
of a semi-objective scale that what you have to do is kind of remember how long and how much the pain was from the honeybee, and then compare that with something else. Say I one time grabbed a cicada killer, which is a great big, huge wasp. It looks like a common wasp on steroids and growth hormones. It's about 5 centimeters long. So this big whopping thing. You don't have them in UK, but the cicada killer wasp is solitary. So it just, mom goes out, catches cicadas, stings them into paralysis and brings them back home to feed to her young, basically. And so she has essentially no major predators because she's not worth the bother of trying to catch this thing to eat. And so I predicted that she would have a very low pain level because she doesn't need to use it. And it turned out when I actually grabbed one, I was out in the field and I didn't have my insect equipment and all, and said, oh gosh, to grab. And it stung me in the palm of my hand. And it hurt a little bit less than a honeybee, but clearly more than a sweat bee. So I could remember those two. So I gave it a rating of 1.5. So I sort of cheat a little bit. I'll give in between ratings with some things that are clearly not equal to a honeybee in this case, but certainly more than a sweat bee. And so that was how I came up with that. And I just do that with basically everything that I run into. In most cases, it's not intentional. Like the cicada killer, I needed that piece of information because I was being hounded by the public. How much these things are? Gosh, they're the scariest thing on earth. They must really, really, really hurt. I said, well, no, theory would say they shouldn't hurt much at all. And yeah, right, Schmidt. Right. You're just afraid to test this thing. Well, the push comes to shove, and eventually, you got to do it. And you can't get them to sting you voluntarily. You can go chase them. You can run after them. You can swat at them. You can stick your nose down their burrow and breathe on them. They're not going to sting you. The only way you can get them to sting you is you have to actually grab it. So that's what I did in this case. But in most cases, say, comparing your common wasps, which should be out by now in the UK and buzzing around buzzing around your sweets factories and those sorts of things. And they, if you mess with those, you don't have to do much to provoke them. You just get in their way and just do anything at
Yeah.
least bit
I was stung
obnoxious, like breathe on them, and they'll let you know they're not happy with you.
Yeah, I was stung by one in late April, was it, Squirl? I can't
Yeah,
remember.
it was.
Yeah, I was doing some gardening and one just dropped into my shoe.
Well, yeah, that's pretty early. Usually there's not enough of them around in April to be much of a problem.
It was very late in April. It was it was very late in the month. But yeah, we had a very warm March and April this year, so they seemed to come out quite early in the UK. Yeah, but one dropped into my shoe and stung the top of my foot.
Ouch. That's better than the bottom of your foot. It's funny that the palms of your hands and the soles of your feet hurt a lot more than the back of your hand or the top of your foot. So you at least picked the right part of your foot to get stung. So congratulations on that regard.
Yeah, they're actually the reason that I'm kind of fascinated with venoms now, is because I used to antagonize them a little bit when I was a kid, and I got stung a lot.
I think that's just being a normal kid. I was that way too. We throw rocks at hornet nests. And
exactly that, yeah.
Just chase bumblebees down their burrow, and they come back out and say, this is my nest. We don't need these big, ugly intruders nearby, and so get out of here. And I got stung by a bumblebee when I was 5, and I still remember that. It was really kind of traumatic experience. But I didn't learn, it's
never do.
Kind of amazing. I just stuck with it.
So with the pain index, did you observe any correlation between the actual pain that you were sensing and eusociality with the species that stung you?
And the short answer, basically, yes. It's like a lot of data that is kind of bumpy along the way, and there's some exceptions and that sort of thing, which is why I had to collect about 80 different categories of stinging insects, that if you just had 5 or 10 or 20, you wouldn't have enough with the noise of the system to come up with any meaningful conclusion. But I finally got enough of them that in general that's basically true. Now there are, like I said, a few exceptions.
Yeah, cool.
The tarantula hawk is one that's solitary, not social at all, yet it has a 4. But if you look at their biology of the tarantula hawk wasp, you can understand why they hurt so much. They're this huge, monstrous, again, 5-centimeter long, gunmetal blue-black wasp with orange wings. And it lives about most of a year. So in the process, it's spending all its time down on the ground looking for tarantulas for its food for its young. So it's susceptible to all kinds of predators, and it needs some way to live long enough to take care of its young and avoid getting eaten. And pain, in this case, is the solution that the wasp has. So that's one of the exceptions.
Yeah. So obviously I'm kind of familiar with the pain scale, and I know that Sarnica you've put on as a 4, so the warrior wasps.
Mm-hmm.
I believe you had some kind of input into the recent Kings of Pain with Adam Thorne and Robert Lever.
Yeah, exactly. Yeah. They were great guys.
Yeah, I mean, I watched it and I enjoyed the show. When they got stung by Sarnica, they didn't feel anything, whereas you rated it a 4. What are your thoughts on that kind of anomaly?
Yeah, well, I think probably first problem is that N equals 1 of me, and it was actually a pretty powerful sting. I was trying to, at the time, we had a guest scientist who was an expert on acoustics, and he wanted to record the sound. They make a warning sound, which is called drumming, where they warn predators, if you mess with me, you're going to be in serious trouble. So we were trying to provoke them to the point where they'd warn us, but not attack us, kind of a fine line. Well, to make a long story short, we blew that, and one of them flew out and stung me on the forehead, and it really, really hurt. It was a hot day, and it did a really thorough sting. So probably if I went back and got more stings, my guess would be I probably would rate it a little bit lower, because I think I got an exceptionally painful one, and I generalized from that, which is why sometimes having several different encounters can give you a better estimate.
Yeah,
So it's
yeah,
probably just a 3.5 or maybe only a 3. I don't know. And I think in their case, they probably captured the wasps away from the nest. So the wasps weren't really trying to defend other than themselves. They didn't really have their heart in the stinging, so to speak. So
yeah,
they were just
yeah.
sort of trying to poke you, saying, "Let me alone. I want to go back home and take care of my sisters and babies. So just let me go. I won't bother you." And so I don't think they had the enthusiasm. Now, if they went to a nest and did like I did and got their nose up close to it and breathed their halitosis breath or whatever their beer breath into the colony, probably they would have come out and found a different story. It's just, one of the things in science that's why we repeat most experiments and most findings is that
Of course.
you can have an anomaly in one time. And I think this is probably an anomaly both on their part and on my part. And the real truth is somewhere in between, which is something, a challenge for others to maybe sort out.
I was wondering if it was anything to do with the fact that they weren't directly next to the hive and they'd actually relocated the wasps.
Yeah, I think that's sort of a factor that it's very hard. The Japanese had noted, 50 years ago that if a Japanese honeybee stings you and it's away from its hive, where it has nothing to defend except its own life, it'll try not to lose a stinger in it. And so what
Right.
it'll do is it'll be like a reverse corkscrew, kind of spinning around and around your arm, trying to gently pull the stinger out without it actually ripping it out of its body. And if
Okay.
you watch it and let it do that for 5 or 10 seconds, it'll actually manage to get its stinger out and save its life. Whereas if you were near its colony when it stung it, boy, it would insert it even deeper and deeper, and then rip its stinger out of its body. So
Bottomize it.
it's a difference in enthusiasm and desire what the insect is doing at the time. And so I think that's one of the factors that most of my stings I was doing, like collecting the colony, harassing them, being really mean and miserable to them. So they went out with a vengeance. They didn't mess around. They went after me.
Right. See, I always thought that you'd actually intentionally stung yourself, and you kind of say you'd picked a spot on your body where you wanted to take that sting. I didn't realize it was just incidental, kind of
Yeah,
as you were collecting.
that's traditional folklore, which is going to survive forever and ever. You can
Yeah,
never
yeah.
overcome that. But it's only been about 6 or 7 that I can think of where I actually had to force them to sting me. And most of these were cases where the information was really of great interest, and yet they weren't very commonly stinging you. For example, one of them is the world's largest ant called Dinoponera. I think
Yeah.
you have some cultures in Sheffield right now in the lab, or at least you used to. It's a monstrous ant. It's about 2.5 centimeters long.
Cool.
It's quite a cool ant, and I call it the gentle giant because this ant is so big nothing messes with it. And it's built like a tank too. It's hard as a rock. So it just runs around the forest floor and picks up dead insects, or if it finds a living one, it'll sometimes grab it. And if it's feisty, it'll sting it to inactivate it. But they never really sting in defense. So I'd worked with them for 3 or 4 years and never been stung. I'd dig up colonies and they still wouldn't sting me.
Right.
So I just decided, people are dreadfully petrified of these things. I had to figure out how much they hurt. So I forced one to sting me. And as big as it was, it's a monstrous insect. It only hurt like about a 2 on the scale, which for something that big, it's pretty remarkable. I would have expected just sheer size alone, it would have been at least a 3.
Yeah, yeah.
But it wasn't just me. My colleague I was working with, a guy named Bill Overall, he reported the same thing. I think he had somehow or other gotten stung, and he said, yeah, it's maybe as much as a honeybee. That's about it. He says, nothing to write home to mom about.
Right. I mean, they are cool. I've seen them. I've seen one of the Canary in the Atlantic forest, and they are big, really big.
Yeah, they are. They're really cool insects.
Yeah, I like them.
That was actually some of the questions we had was around your rituals to prepare yourself for envenomations. However, talking to you and actually understanding that a lot of your envenomations was by accident is actually quite interesting. I think it's quite
Yeah, yeah, most of them are. Like the most recent sting I had was last week. We have common paper wasps that nest, the open face nests under the eaves around houses and that sort of thing. We have a couple of colonies by our doors in our house. I just leave them there because they're kind of pretty. They're yellow and they come to our swimming pool and land and hover like a helicopter. And they're just kind of fun to watch them. They're kind of interesting creatures. And they eat caterpillars, so they're basically beneficial. And they usually don't harm anybody. They've been there for every year for years we've had them. For some reason, I walked out about a week ago, and one of them flew down, stung me right on the end of the nose. It was kind of as if she was the omega wasp that had been beaten up by all of her sisters in the nest, and she needed to come home and kick the dog. Well, I was that dog, and she stung my nose. Boy, that hurt. I looked like Rudolph for the next day with this bright red nose.
No,
That's actually quite interesting that you say a lot of them are. Oh, everything okay?
yeah, I'm just breaking things. It's all right.
It's not usually you that makes all the noise, Squirrel.
I know.
It's usually the other host plays the drums. So you kind of the way you articulate the stings during your my words really aren't coming to me today. The way you articulate each sting is very similar to kind of how a wine connoisseur would describe a wine. It's actually quite incredible. So kind of, was this planned from the start, or did you just kind of come to you on kind of how you'd like to describe it mid-pain?
Yeah, I think it was kind of a later thing because originally I just figured I'm just a scientific nerd. Nobody cares about this, and I'm just trying to answer a question and get my PhD completed so I can actually go out and do real things in the world, just kind of survive. So I wasn't really thinking of that. But then after about, about mid-90s, so that would be about 20 years, I realized that people are interested in this subject and that you have to communicate, your love and interest in science, whatever you're doing, you want to excite other people that this is really like cool stuff and look at this, it's really exciting. And I realized that giving them numbers like 1, 2, 3, and 4 puts you to sleep faster than anything you can imagine. We're a species that we communicate by words and especially by music, dance, and visual images, arts and this kind of thing, and smell. And that's what the basis of wine tasting is taste and smell. I thought, yeah, they've done a good job of getting through to the making something understandable for everybody. So I said, yeah, we can do the same sort of thing for the stings. It gets your emotional connection with it, and then you can look at, in the book we had a sliding scale which shows a ball moving along a little line. The further it goes along the line, the hotter it is, so to speak. Yeah. So that combines the visual with the creative design, and then you got the number, which is what scientists use for crunching into the computer and coming up with answers. But I thought we actually need all 3 systems in order to communicate properly. So that's pretty much a genesis of where that came from.
Yeah, it's quite an interesting way that you describe some of your stings that you've had. So, out of all your stings, what has been one of the most unusual reactions that you've actually had from them?
Probably the most unusual reaction I've had was from a velvet ant, Dasymatilla klugi, which is a great big wingless wasp. They call them an ant because they're ant-shaped and they don't have any wings. And I got the sting there, and it's very itchy. It's kind of like the common nettles that are along wet areas, kind of a rashy thing. You kind of rub it, and the more you rub it, of course, the more it hurts and that sort of thing. But you just have this urge to rub this thing. What was so unusual about these stings is it seems idiosyncratic to me and not to anybody else as far as I know. So about 2 weeks later, wherever I got stung, I peel off a big chunk of skin, pretty much like if you ever had a nasty sunburn in, a couple of days or a week later, your skin, kind of peels off. It's sort of that same idea that a piece of skin would peel off. It didn't really hurt or anything. It was just an unusual reaction. And that wasn't to do with pain. It was just, unusual as far as the strangest reaction.
Yeah, that's quite an interesting reaction. To Sorry, I'm really struggling with my words today. My mind's just not keeping up with what I'm trying to say. So I apologise there. So the entire pain index is available from your most recent book, which is The Sting of the Wild, which has a really good blend of storytelling, natural history, and toxinology. What was something that you set out to achieve with it, with the book, and kind of is it all inclusive within that?
Basically what I wanted to do is kind of tell a story of a love affair with science, and in specific with stinging insects. And the reason I think stinging insects are important is that if you can make the most scary insects, come to life as real interesting creatures that deserve, to be alive and do interesting things and are fascinating, worthy of study and worthy of admiration. If you can make them interesting, then my point is you can make anything interesting. And it just shows, I suppose the next challenge would be for somebody better than me is to write something on cockroaches, because I'll bet you there's a lot of things interesting about cockroaches. And in spite of us not liking them, I think we could make cockroaches lovable as well. And that was what I was trying to do with stinging insects, is basically reach out to the audience, and especially the young people, that, hey, biology and life is important and natural history is important, and we're all on this earth together, and we need to stick together and protect it, and not just willy-nilly spray poisons around and kill all the insects and things. That's, not the way to go. More cherish them and honor them and see what good they do. That basically all these stinging insects that I wrote about have some beneficial features to them, and so we should cherish what's good about them and learn how to kind of just get by with the things we don't like about them.
Yeah, exactly, and I think people don't realise how much insects are being hit compared to what megafauna and mammals are. For instance, I think there's a big light on mammals and the extinction activities within mammals, but not necessarily.
Elephants are in danger.
Yeah.
We don't notice when most insects are. The kind of the big exceptions, fortunately, are the pollinators, especially the bumblebees. As turning out, the bumblebees are pretty much around Europe and at least North America in kind of a free fall, that many species are getting much more scarce. They're losing their range of habitat where they were usually found. Some of them are actually gone extinct. And there's a lot of reasons for this. Mostly it's just that we're doing bad things to the environment of bumblebees, especially the insecticides and things of this sort that we're overly applying to crops. And we need bumblebees not only for making our food, pollinating our food crops and that sort of thing, but just for, life living in a concrete tunnel is not very interesting. And if we turn the whole world into a concrete parking lot with not much else life there, my feeling is life's not worth living in a situation like that. We like the beauty and the complexity and the diversity and just the absolute ability to admire what a marvelous life this is on Earth, and that we're part of it, and we're lucky to be part of it, and we should cherish this.
Yeah, I think as well, as far as kind of looking at insects go compared to mammals, there's a lot more going on, just, well, all over the place, really. Obviously, there's the venoms, things like that, but just some of the, like the reproductive strategies, for instance, where you get hybridization and they can choose a caste based on the partners that they've, the species that they've bred with, things like that, that you just don't see in mammals.
Not much, no. Sheep are one of the exceptions, that sheep can pretty much breed throughout just about any population of them. yet they're called different species of sheep. We have what's called bighorn sheep here,
Yeah.
yet they can interbreed with Dall sheep, which is up in northern Canada, and they can breed with some of the sheep from which are, of course, different species in Asia and all that. So there's some of that going on in mammals. Sheep are probably the most extreme example, but basically what you say is essentially true, that we usually see things that are staying isolated.
Yeah, and the fact that the queen can actually differentiate between the sperm, and she can make reproductive females from her own species, and
Yeah, that's
and
the one thing I'm really grateful that we can't do, at least not yet,
yeah,
in our species. The mama of the wasp bee or ant can determine whether she wants to make a male or a female by whether it's fertilized, because they have this unusual genetic system, unlike us, where we get half our genetic chromosomes from our father and half from our mother, and if we just have one of them, say the mother or just the father, well, we just die as an egg or as a sperm, in which case nothing more happens. But in the case of Hymenoptera, if you have just one partner, in this case the mother, that throws in her set of chromosomes, it'll become a male. And if she gets fertilized by putting a sperm in from a male, then it becomes a female. So she can decide, oh, I've got this bag of sperm that I've stored up for my mating, and I can release a sperm or two or three when the egg's going down my oviduct and about to be laid. I can release a sperm or two or several and make it into a female, or I can decide, no, I want to make it into a male. And this is really useful in the case of honeybees. If you had, say, half of them as males, all they do is eat honey and take up room and cause trouble. Typical males in that regard. So you don't want too many of those. You need enough to, of course, fertilize future generations of queens, but you
Hello?
with us, with other species.
Yeah, I think that's quite interesting. So, what are the actual triggers that they use to decide if they should be laying male or female eggs?
Female, young. We don't really know in most cases, or in any case that I know is confirmed. We can correlate, though, in the case of tarantula hawks or cicada killers, which are two really big wasps, that in which case the tarantula hawk stings one tarantula and gets one young off the tarantula. If it's a really big tarantula, say a nice fat juicy female, then she typically fertilizes the egg and produces another female tarantula hawk. The reason is female tarantula hawks do all the work. They have to be big and strong and hardy, whereas males are just, just flutter by, and all they have to do is mate with the female. They can be scrawny little runty thing. It doesn't make any difference how big they are. So if it's a small tarantula, say a male or an immature, which isn't very big, she tends to lay the egg without fertilizing and produce a male, because a scrawny male is at least some value for passing on your genetics to the next generation, whereas a scrawny female is pretty much a dead end. She won't be able to do much of anything. So rather than just losing the opportunity and saying, well, I got this scrawny tarantula, what can I do? I just forget it. No, you just make a male, and that way you have some benefit out of it. And the cicada killer does a similar thing. The ones I study, the Western or Pacific cicada killers, they'll catch one or two cicadas. If they catch one cicada, then some years there's a really high competition, shortage of cicadas. And so if she just gets one, she'll lay a male egg on the cicada, because again, a small male, all he has to do is mate with a female. He doesn't have to be strong enough to carry this big whopping cicada, which may weigh more than the wasp that's actually carrying it. So he doesn't have to do any of that, but the female has to be really big. So she'll make sure that she gets two nice, juicy, plump cicadas that she fertilizes the egg and produces a female. So there's obviously some sort of decision making that the females make. They're recognizing something and they're able to act on that. But just exactly how they do this, we don't know. We just know that we can correlate what we see with what ends up as a final result, which makes sense to us, and it somehow or other must, quote, make sense to the female wasp as well.
It's quite an interesting evolution that they have to be able to do that. It's
a level of cognition that people don't associate with insects necessarily as well.
Yeah, exactly.
Yeah, the best studies are actually done with honeybees and bumblebees that they've been shown to be able to learn quite efficiently. In fact, just recently it was shown that honeybees can have a concept of zero, nothing, which is actually pretty profound. You know, we think of distinguishing between 1 and 2 or 1 and 3 or 2 and 3, you know, these sorts of things. We sort of see a couple of objects there, and yeah, we can tell the difference between two things in one side of the table and one thing on the other. We can distinguish that. That makes sense. But can we distinguish between one stick on the right side and nothing on the left side? That's a whole different question. And it turns out honeybees can do that. So if honeybees can do that, I wouldn't be surprised if a whole lot of other insects are actually quite a bit more capable than you know we often credit insects with.
I think it's due to the fact that an insect's brain is not necessarily the same genetic makeup as a mammalian brain, and people struggle with that concept.
Exactly,
well.
and I think it's actually much more efficient in terms of what they get out of an individual nerve cell. You know, we have some 10 billion or something, some huge number of neurons, nerve cells, and they just have in the order of a million or less, sometimes just tens of thousands of them. Yet they can still quite nicely, you know, get along with life, find their way around, and function pretty effectively.
And as you say, be social, and a lot of the social behaviors that a lot of them show are very complex as well.
Exactly, especially ants. That's why there's such a love among entomologists for ants, because they're just so amazingly diverse. Whatever you want to study, you can find some ant species as an excellent subject for that study.
Yeah, well, definitely. And I think some of the colonies that you go to zoos and such forth and aquariums and that, and you always find even the general public will spend a lot of time around the ant, the colonies and nests.
Yeah, the leafcutter ants are particularly fascinating. How they're actually gardeners, just like we domesticate and grow crops. They do the same thing. They grow, in their case, mushrooms. They have a little higher taste than we do. They like mushrooms, whereas we eat collards and broccoli and Brussels sprouts and things that people would say, why on earth are you eating these nasty tasting things? Well, we just learned to like them. But everybody loves mushrooms, and that's what the ants eat.
Yeah, leaf cutters are really cool. I work in a public aquarium, and I take care of a decent sized colony of Atta and they're probably one of the biggest draws as far as all the inverts that we've got go. People seem to just love watching them carry the leaves from one place to the next, and then what's going on in the fungal colony and the actual kind of farming of it. People love seeing it.
Yeah, you never get bored watching them. I see a lot of them. We have not that species, but we have leaf cutters around here in Arizona.
Yeah.
And you're walking along in the road and you just see this string of leaves, and how can you not be fascinated by these leaves marching along the side of the road?
Exactly.
They are pretty cool. I'll give you that. They are pretty cool.
The only downside is that they don't have venom, and that brings them down slightly for one.
That's my disadvantage. Unfortunately, they have spines and they have big jaws for mandibles biting, but they don't have any venom, which is kind of a disappointment for me.
Yeah, definitely.
Yeah, especially compared to some of the counterparts that do have venom. They're very different, aren't they? So, just with an eye on the time, I think we've covered our complete agenda. I think, and that has been quite funny. I've had to mute myself quite a few times from laughing at some of your stories, especially about some of your stings. they are particularly funny. So thank you so much for coming on, Justin. That it's been great to have you on and talk to you about your work and talk to you about what you've done in the past and how you've got to the position you're in and the work that you've done. And it's been great. So thank you for coming on.
Thank
It's
you.
been my pleasure, and thank you so much. Go ants, wasps, and bees.
I think most of our listeners will definitely agree with you with those remarks as well. So again, I'd just like to thank Justin for coming on, and I'd like to thank our listeners for listening to the show. We would just like to thank our listeners for listening to this episode of this podcast. Please remember, you can listen to all our previous episodes on your preferred podcasting platform.
We would love for your feedback and ratings, as this allows others to find, listen, and share the stories and work of our great guests.
Good night, and please enjoy this podcast.